dish, in case you've never had to shell it. One year I didn't put it on the board and I got peach tree on somebody's quiz. Petri dish, not peach tree. Petri dish and plate are the same thing. It's two terms for the same piece of equipment. A Petri dish is a plate in microbiology. And ours are plastic. They've got a lid. And then the auger is in the bottom. The lid is much shorter, right, than the bottom. You want to, when working with these, not leave them open for very long. Okay? I don't want to see any of this. When I walk by and your Petri dish is just open, sitting there, and you've got your loop over here and you're talking to somebody, you leave it open that long, fungi and bacteria in the room are falling in and contaminating it. Okay, so lids stay on until you're ready to work with it. Now, when you go to label these with the bacteria that you're putting in, you always write on the bottom, on the side that has the auger in it. Because if you have 10 Petri dishes and you've labeled the lids and you take the lids off of 10 Petri dishes, how do you know what's in here anymore? Because the lid's labeled, not this. So, always label the side that's got auger in it with the bacteria that you're putting in and you're grouping. And you want to try and do that writing as small as you can along sort of the edge. Right? You don't want to write B subtilis, and then next time you can't see through your writing. Okay, so try and write small and kind of off to the side. All right, so you can do that first. Label it with the bacteria that you're using. You do that with your Sharpie markers right there in the back drawer on the bottom side. And while you're labeling, also draw yourself a T. You want to divide this plate into 4 sections. Okay, you're doing, again, you're writing this on the auger side of the Petri dish. What we're going to do with the streak plate is spread the bacteria across the surface. And what we're looking for are isolated colonies. What we want when we're done is to have isolated colonies. An isolated colony is a mound of bacteria, not touching any other mounds of bacteria. That's why it's isolated. A mound of bacteria, not touching any others, that all came from one original bacterial cell. So big mound of bacteria, not touching any others, that originally came from one bacterial cell. Aseptic technique, we're going to follow the first 4 steps exactly the same. Flame your loop, flame the opening of your stock culture, pick up your bacteria from the stock culture, flame the opening again, put your lid back on. So, we're assuming now that I've got a loop here that has bacteria on it. Right. The way I like to work with this is to keep my Petri dish with the lid down so I can pick up just the side that has auger in it and leave the lid there on the table. Works better for me that way. Okay, but you do it however you want. Okay. So, switching to my pen, let's pretend this is my loop that's got bacteria on it. What we're going to do is spread them out. Should be a nice continuous line in the first section, whatever section you decide is first. Right, so doing that with the real Petri dish, again, pretend that I've got bacteria on this. You want to, again, move your whole arm. You don't want to move your wrist. You're going to dig into the auger if you do that motion. Okay, so hold it level, move your whole arm to streak back and forth. Then you put it down, because now you got to flame the loop. Okay, you dipped it into bacteria, you spread them out in the first section, and then flame the loop, same procedure, make sure the whole thing turns bright orange. Slowly pull it through, whole thing bright orange. So, the streak plate, spread them out, then flame the loop. What does that do?
Kills the bacteria.
Kills the bacteria on it. It's sterile now. Again, let it cool for a few seconds. If you were to try and touch it to the auger, it would sizzle, you'd be killing stuff. Okay, so let it cool. Then you're going to take that loop and touch it to the auger in this section where you spread out the bacteria, and keep it pressed against the auger and drag them into the second section to spread them out. Okay, so we're not going back in the stock culture. We're taking the bacteria from this section and spreading them into the second.
You going to the third though?
Not yet. Let's why you drew yourself a T, so you know where the second section was. Where is there more bacteria?
First.
In the first section, right? This should have less bacteria in it. And you flame the loop again, which does what? Sterilizes it, kills the bacteria on it, let it cool for a few seconds. Then you're going to go into the second section with your cool, sterile loop, drag those bacteria into the third and spread them out. Notice I only did it one time, one zigzag. You don't want to do this and go back over it 15 times. Okay? One zigzag is all you need, because we're trying to spread them out as much as possible, not pile them on top of each other. Okay, so don't do that. Any guesses what we're going to do right here? Flame the loop. Same reasons, kills the bacteria, let it cool for a few seconds, and we're going to do this one last time. Okay, drag the bacteria from the third section into the fourth and spread them out. And again, every time you spread, try and remember to keep your wrist straight, that you're moving your whole arm, you're not doing this. Okay, if you move your wrist, you're going to dig into the agar, make little tracks in there, and other microbiologists will make fun of you. I don't want that to happen. So, good work. You want to stay on the surface, but not dig into the agar. We won't be too hard on you today because it's your first time. The more practice you get, the easier it is. Okay, but again, move the whole arm to try and keep a light touch. And then last thing you do, flame the loop. That's always the last thing you do before you put it away. Right? Make sure you kill any bacteria that are on it. Obviously, let it cool off before you put it away. So, once you've done that, you're only doing one Petri dish for this. And the stock culture that you used for this one says mixed. The one over here in the separate test tube rack, it says mixed on it. That's because there are a couple of different types of bacteria in here. I can shake those for you guys. A couple different types in. So that's the one that you want to use, mixed culture. And if it's all gone well, after we incubate it, we should see isolated colonies. Right now today, all you're going to see are your streak marks. Right? So when you're done with that, it goes into the incubator as well. So same time and temperature, 37 degrees, 18 to 24 hours. The only difference is this plate or a Petri dish has got to be upside down. You want to put it in the incubator with the lid facing down. And you can see on this lid there's lots of condensation in there. Agar's full of water. If you have the lid up, water is going to evaporate out of the agar, hit the lid, turn into liquid, and then fall back onto the surface like rain. And then all that water is going to smudge your streaks. And you don't want that to happen. You want that condensation to collect on the lid with the lid upside down. Okay, so agar up in the incubator. Incubate it upside down, agar up. That keeps the condensation on the lid away from all of that work you just did. Alright, so assuming it went well, when we come back on Monday, in the first section, draw your T, this is after incubation here. The first section, what you should see is a thick line of bacteria that had the most in it, right? And then the line should get thinner in section 2. And by section 3, it won't be complete. It'll be like a dashed line. There weren't enough bacteria in section 3 to make a solid line with your streak. And by section 4, you should have what we want, little dots. Those are the isolated colonies that we defined earlier. Little mounds of bacteria, not touching any others, that came from one original bacteria. So today, you streaked them out so that there was one bacteria right here where that X is. And then when you put it in the incubator, that one bacteria grew and divided and became 2. And those 2 divided to become 4, and 4 become 8, 8 becomes 16. So when you come back on Monday, you see one whole pile of a couple thousand of them piled on top of each other, but they're all genetically identical to the one you spread out today. That's the parent of all of those. Does that make sense? Okay, get to it.